Hello guys, welcome to Code Champ. My name is Nikita and in this video we are going to study how does deletion operation is performed on linked list. Okay, so in the last videos we are running one playlist in which we are going to learn different operations on linked list. So we have covered up till now creation, traversal and insertion of node at three different positions, like at the beginning, at the end and in the middle. So similarly for deletion also there are three different cases. You can delete a node at the beginning, so like this is the first node, you need to delete this. Okay, otherwise you can delete a node which is the last node, that is at the end, and any node in between. In the middle, if there are any nodes, you need to delete that. So there are three different cases. Okay, so let us go to our code and see how are we going to perform this. So this is our last code. I'll just execute and we'll see what is the recent linked list which we have is this one. Okay, so like first of all we'll write one function to delete a node which is at the beginning. Void delete from begin. Okay, so delete from begin or delete from start, you can say delete from start. Now how to delete from start? See, head start is stored where? Okay, start is stored inside the head. So you need to update this head pointer. First node is going to be deleted, it means head should point to second node. Alright, so what we can do is head should be head equal to head arrow next, and then we can delete this node. Alright, so let us see how can we do this. Is head should be equal to, so our head is in capital, head value we need to store inside some temporary pointer. We will consider temp equal to head. Okay, so head is stored now. Head should be shifted to the head arrow next. Alright, so head will point to the second node and the first node should be deleted. So first node was stored inside temp, that's why we can free this using temp pointer. Don't do a mistake of freeing here head pointer. It will like, see, it is pointing to the first node of the linked list and you are freeing that node. It means you no longer have access to linked list. So that's why we have taken one temporary pointer. Okay, so free temp, that is it. So first node is deleted. For deleting a node which is present at the end, delete from end. Again take one temporary pointer. Why? Because see, I will tell you. Now for deleting a node which is at the end, this one, you need to come to previous node, right? So like from temp is equal to head, temp arrow next is not equal to null, till then you need to come here. Okay, so here you will come and then temp arrow next you can directly set as a null. So see, first of all temp is starting from here. Okay, then temp equal to temp arrow next, then temp equal to temp arrow next, temp equal to temp arrow next, temp equal to temp arrow next. So this will be the last node which you want to free, and this is the node where which pointer should become null. Alright, but if we like move the temp, like temp equal to temp arrow next, or check that temp arrow next is not equal to null, then if you see, there is one problem. Temp will reach to the last node. If it is reaching to the last node, how we will update the previous node, right? So we should move the temp till temp arrow next. This is the temp arrow next, and going to next of that node should not be null. So temp arrow next we need to check. So how we will do that is while temp arrow next, because we need to come to the previous node and stop. That's why. Okay, that is the second last node in the linked list. So while this is not happening, you need to move temp equal to temp arrow next. Alright, after that, when you come outside of this loop, now the node temp is pointing to the second last node. What we need to do, this is the second last node, so temp arrow next should become null, and before making it null you should free that, right? So temp what you should free, you need to free temp arrow next. See, observe properly, we are not freeing temp pointer, we are freeing the value of the next of that temp pointer. So 400, so the node at 400 will be freed, that is this one, the last node. And after freeing that, simply temp arrow next you need to set to null. So this is how we delete a node at the end. Now very challenging, huh? We need to delete a node which is in between. What we will do? See, this is the position. You consider this is the wait, this is very messy. Let me clear this first, and then we can focus properly. I'll take one pen. See, this is the third position. I want to delete this node. Alright, how I will delete? So first the loop will remain same as we used for the insert and middle purpose. I'll just copy that node first, that code first, and then we will proceed. So void delete in, delete from middle. Alright, so you will require a position for this. Int position I'm taking. This is my for loop. Again the condition is same, because you need to come to the, like, you need, if you want to delete a third node, your temp should come to the second node. Alright, and after coming to second node, see, this is our second node. If temp is pointing to this, so this node you need to delete. It means this pointer should point to the last node, or you can say next arrow next, because temp is pointing to this now. So temp arrow next should become temp arrow next. Alright, and then you need to free this node. Alright, so let us do that. This for after coming out of this for loop, our temp will be at the previous node, like position -1 position location. So that's why temp is going to point to the, like, second node if you want to delete a third node from the linked list. So it will come to the second node. Now third node you want to delete. Okay, so third node is what? But how you will assign is temp arrow next. Temp arrow next should become now what? Temp arrow next means this, instead of 300 now, here it will say 400. Alright, but before that, what you want to do is you need to, before removing this node, 300, the node which is at 300 address, you need to free that. So how you will free that? So to free temp arrow next, you need to store somewhere. So simply what I will do, I'll take one more temporary node, delete node, I'm calling it spelling. This should store temp arrow next, that is the third node address. Okay, and I'm storing this, and then after storing I'm assigning the last node, or you can say fourth node address. I'm storing inside temp arrow next, and then I need to free this. So temp arrow, no, see, in the previous line you are updating temp arrow next. If you free this here, then you are gone. That's why I have stored it here. You need to free this, and then our work is done. Our functions are completed. We'll use and we'll see what is the result. Okay, so delete from start first of all. Okay, and after deleting we'll immediately display, so that it is visible to us what is happening, how the linked list is changing. Delete from end I am calling, and then again display. Now from middle I say from third position I need to delete. After deleting again I am displaying. Okay, that's it. Alright, so let us see how does it change our linked list after deleting. So one by one, first we are deleting from start. See, this is the insertion. Till here we have done insertion. After that I have performed delete from start. So starting node, in the next list, if you see properly, the first node holding data 9 is deleted. Afterwards, if you observe properly here, see, the last node is deleted, that is 41. Then deleting from middle, third position. So in the previous our linked list, third position node is 20. So if you observe in the last linked list, 10, 25, 20 is deleted, 30, 40. So our functions are working correctly. So go fast and execute this. Follow the same process as we have followed in this video. Go stepwise and execute this, so that we can proceed with our further operations in linked list. So keep watching. Thank you guys for watching this video. Enjoy coding, keep coding.